So this is Math 114, 4.5, System of Linear Inequalities. So we have that. Like I said, Objective 1, use mathematical models involving system of linear inequalities. So a system of linear inequalities, a solution of system of linear inequalities in two variables is an ordered pair that satisfies each inequality in the system. What does that mean? So let's say we have, well, that's not straight. So let's say we have a graph. And we have that line that is solid. And we say that this is an inequality, so we know we're going to be shading like we did on the other one. And then we have another one that has a dotted line. And we shade this side. For this to be true, my true solution for this is this part only. Everywhere the shading crisscrosses, that will be my solution. This is not my solution, and this is not a solution because they're not crisscrossing at that point. For it to be a solution, the answers must be crisscrossing. For instance, A and B, B is right there, A is right there. These are solutions because it is within the shades, as same as here. Okay, if we had a point, let's say over here, let's name that C, this would not be a solution. Same if we had one here, let's say that D, that is not a solution. So let's look at this. We said the healthy weight region for men and women ages 19 to 34, shown in figure on the previous slide, which is this, can be modeled by the following system of linear equations, which is these two. Show that point B, which is right there, is a solution of the system of inequalities that describe healthy weight for this age group. Okay, so first of all, I think, yeah, we're almost out of space, so let's get another sheet. Let's get the inequality systems, and it's 4.9x. So we have 4.9x minus y, 16.5. The other one was 3.7x minus y is less than or equal to 125. So we have this out, and what else did it said? Show that that point, which is point B, was 66, 130. And it wants to know if this is true, if this would be correct. Well, we just plug in. We already know how to do this, which is 4.9 times 66 minus 130 is greater than 165. So let's get a calculator out. So I have 4.9 times 66 equals 323.4 minus 130. So minus 130. So I have that this is 193. Let's leave that in decimals. 0.4. So this is true. Let's see if that's true for the next one, though. We have to be for the both of us, for both of them. So let's do this one on red. So it's 3.7 times 66 minus y, which is 130, is less than or equal to 125. So I have 3.7 times 66 equals minus 130. Leave that in decimals again. And we have that 114.2 is less than or equal to 125, which is also true. And as the graph shown, turns out that this is a solution for the system. So graph the solution sets of system of inequalities. The solution set of a system of inequalities in two variables is the set of all ordered pairs that satisfy each inequality in the system. To graph a system of inequalities in two variables, begin by graphing each individual inequality on the same graph, then find the region. If there is one that is common to every graph in the system, this region of intersection is region overlap gives the system solution set. So that's what I said a minute ago. For them to be solutions, they must overlap. So let's start graphing. So I have 5x plus 2y 10 minus 5x to both sides. So I have 2y minus 5x plus 10 divided by 2. So I have y 5 over 2x plus 5. So that's going to be my first line. 2x minus y is greater than or equal to 4. Minus 2x to both sides. So I have negative y. Negative 2x plus 4 divided by negative 1 on everything. So I have that y is less than or equal to x minus 4. Of that means now we're ready to graph. This is y. This is x-axis. So the first one was 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the first one's in black, so it's telling me to go up 5. 1, 2, 3, 4, 5. And it's telling me to go 5 down and 2 to the side. So that's my first line. Since I'm not passing through 0, 0, I'm going to use origin to test. Then have 0. So is 0 less than or equal to 5? Yes. Since origin is this side, I'm going to shade on this side. Then I'm going to graph this one. It's telling me to go down 4. 1, 2, 3, 4. That's going to be my first point. Then I must go up 2. 1, 2, and 1 to the side. Again, I'm not going through origin. Then I'm going to use 0, 0 to test. So I have 0. 2 times 0 minus 4. So is 0 less than or equal to 4? No, it's not. So that means that we have to shade to the other side. And we can see that it's crisscrossing. All the answers are crisscrossing there. So that is our solution. So let's this one be red now. So x plus y is greater than 3 minus x to both sides. So I have y is greater than negative x plus 3. Let's do the other one. Let's name that orange, gray, yellow. So I have I have x plus y, negative 2 minus x to both sides. So y is negative x minus 2. So the red's telling me to go up 3, 1, 2, 3. Then go 1 down and 1 to the side. 1 down and 1 to the side, right there. So these are dotted lines because it does not have an equal sign. Then I'm not going through origin, so I'm going to use 0, 0 to test. So I have 0, 0 plus 3. So this is false. So since this is false, that means that I have to shade opposite of where origin is. Then the next one's telling me to go down 2, 1, 2, and 1 to the side. And then 1 down. Sorry. 2 down, and then 1 down and 1 to the side, like this. This looks like they're parallel to each other. I'm still going to use 0, 0 to test. So I have 0. So 0 is, so this is true, so I must color where they crisscross. So this one will go so that means my solution is all of this.